Alright, the Chapter 5 Test Study Guide. The first question asks us to change the degree measure to radian measure. So the conversion factor we need is that 180 degrees is equal to pi radians. Let me just do a base conversion. So 140 degrees over 1, we multiply by the conversion factor, degrees on bottom, radians on top, and pi radians goes with 180 degrees. And then we want exacts. We leave pi in the answer, reduce the fraction of all those terms. Both numbers end in a 0, 14 and 18 both divided by 2. So we get 7 pi over 9 radians. Number 2, length to the nearest tenth of a centimeter of an arc that subtends a central angle of 105 degrees. Radius of 15 centimeters. The arc length formulas, we have two of them. The one involving angle measure as in degrees is the arc length is equal to the angle measure over 360 times the whole circumference of the circle 2 pi r. So d is the angle measure given to us here in degrees, r is the radius given to us here in centimeters. So the arc length in this case is going to be 105 over 360 times 2 pi times 15. And at this point I probably need a calculator. So this is the nearest tenth of a centimeter, so I would just type in 105 times 2 times pi times 15 divided by 360. And do make sure to use the pi button. 27.4889 rounds to the nearest tenth as 27.5 centimeters. Wheels rotating at 14 revolutions per second. Find the angular speed in radians per second. So the main thing here, we got to change revolutions to radians. The per second's already there. And 1 revolution is equal to 2 pi radians. So if I do 14 revolutions per second is our initial unit, I'm going to change revolutions to radians. So revolutions on the bottom for cancellation purposes, radians on top to convert. 1 goes with rev, 2 pi goes with radians. Revolutions cancel revolutions. And 14 times 2 is, so we get 28 pi radians per second. I'm not sure it'll be that basic on the test, but angular measure, revolutions, radians, degrees, times, seconds, minutes, hours, it'll be along those lines. It won't be too much conversion. If I had said radians per hour, let's say instead of second, now we've got to change seconds to hours, so 60 seconds in a minute, and then 60 minutes in an hour. And now all of a sudden we have radians per hour, 14 times 2 pi times 60 times 60, whatever that comes out to. So just be aware that I'm not going to shy away from changing the speed and the time. So just keep that in mind. Make sure you look at the question carefully on the test. Number 4, a wheel with diameter of 40 centimeters, that means the radius is 20 centimeters, is rotating at 250 radians per second, that is an angular speed. And we want the linear speed in centimeters per second of a point on the edge of the wheel. So the linear velocity of anything is equal to its radius times its angular velocity. And again, be careful, it does say diameter, make sure you give me a radius, that's what the formula needs. So I can immediately go straight to the answer here. 20 centimeters, I'll put that over 1, times angular speed of 250 radians per second. And if I multiply it out, 25 times 250 is 5,000. And that's going to be centimeter radians per second. It does ask for the answer in centimeters per second. The unit of radians is one that can be thrown out if we wish. So I throw that out, leaving me just with centimeters per second. Again, that's pretty basic as far as this type of problem is concerned. If I ask for a different unit, such as let's say feet per minute, or miles per hour or something like that, at that point, once you get the radians out of the way, then you just got to convert to whatever unit it is, 2.54 centimeters an inch, 12 inches in a foot, 5,280 feet in a mile, that kind of stuff, to convert to miles per hour if we had to do that. Also, if it's not radians to begin with, if it's, let's say, revolutions, once again, 1 revolution is equal to 2 pi radians. It has to be radians to be thrown out. So if it's not radians to start off with, you have to convert to radians first and then throw it out. The 2 pi will be stuck because of that. Number 5, theta is an acute angle of a right triangle. So we have a right triangle. Theta is going to be living in one of these corners here, one of the acute angles. And they tell us tangent of theta is 2/5. That means the opposite over the adjacent of theta. So if I drew theta over here, the opposite side is 2, the adjacent side is 5. The hypotenuse is, by the Pythagorean theorem, h squared is going to be 25 plus 4. So h squared is going to be 29. So h is going to equal the square root of 29. Okay, they asked me to find secant of theta, and I recall that secant of theta is equal to 1 over cosine of theta. So if I can figure out cosine of theta, cosine is adjacent over hypotenuse. In this case, adjacent 5 over hypotenuse is the square root of 29. That means that secant of theta is going to be the reciprocal of cosine, so it's just going to be the square root of 29 over 5. Now, I could have fixed this to make it 5 times the square root of 29 over 29, but knowing that I had to reciprocate it immediately got me to a nice rational denominator, so I don't have to worry about that. If it asked for a cosine, then of course you'd have to fix that, make it 5 times the square root of 29 over 29. Number 6, exact value of tangent of pi over 3 cosine of pi over 4 minus sine of pi over 6. You're allowed to use your formula sheet, the blue formula sheet I had printed out for the test before. So I just look up tangent of pi over 3 on the sheet. I can see that that equals the square root of 3. It does say exact, so it means leave radicals as is. If I look up cosine of pi over 4, that's going to be the square root of 2 over 2. Those are being multiplied together. So cosine of pi over 4 is the square root of 2 over 2. And then minus sine of pi over 6. If I look that up, pi over 6 sine is 1/2. Okay. And once I get all those exact values, then it's just a matter of simplifying this expression as much as possible. This officially is over 1. Square root of 3 times the square root of 2 on top is the square root of 6 over 2 on the bottom, minus 1/2. And if you just put it all into one simple fraction, they have a common denominator already. If they didn't, you'd want to get a common denominator there to add them or subtract them. Can't really subtract square root of 6 minus 1, so that's the best answer possible for that problem. Exact coordinates of the wrapping function of 2 pi over 3. That simply means the cosine of 2 pi over 3 paired with the sine of 2 pi over 3. And again, you're welcome to use your sheet for this. The cosine of 2 pi over 3 is negative 1/2. The sine is the square root of 3 over 2. So just make a ordered pair, cosine first, sine second, of whatever the angle is. And again, use your sheet. Find in the radian measure 2 pi over 3, then cosine and sine are right there. You can find what they are. Number 8, amplitude, period, and phase shift for the function y equals 2 sine of 4x minus pi. So first thing, y equals 0 plus 2 sine of 4 parentheses x minus pi over 4. You always want this to be x right here, so whatever's in front of x needs to be factored out. And if it's factored out, it's dividing both objects. So 4x divided by 4 is x. Pi divided by 4, of course, is pi over 4. That means that a equals 0, b equals 2, c equals 4, and d is equal to positive pi over 4. Whatever this sign is, you always change the sign for d. The amplitude is b. Positive if it's negative, so if it said minus 2, it's still going to be positive 2. So amplitude is always a positive number. Whatever the positive version of that number is what the amplitude is. The phase shift is whatever d is, which is pi over 4. So amplitude is b, absolute value of b. Phase shift is whatever d is, sign included, positive or negative. As far as a period is concerned, we got to look at the original period for the function, which sine, the original period is 2 pi. We have to divide that by whatever c is. That comes out to pi over 2, so the period of this is pi over 2. No graphing necessary on that. I just want you to identify amplitude, period, and phase shift. Identify them as what they are. I asked for them in that order. I put them in this order. Just make sure you've identified them for what they are, and I'll be fine. Expect it to be sine, cosine, one of those types of functions. probably on that problem. This one's a tangent, so expect maybe a tangent and cotangent on this one. Period and phase shift for the function 7 tangent of pi over 6 plus x plus pi over 2. So once again, if I start off, and I should say y equals, I left that off, but y equals. All right, 0 plus 7 tangent. Once again, I want this to be x, not pi over 6x, so I'm going to factor out a pi over 6, x plus. Now, some of you might get messed up a little bit with factoring a pi over 6 out, but all I'm doing is I'm going to take pi over 2, the number that's there, divide by pi over 6. That's what I'm taking out. Divide by a fraction, same as multiply by the reciprocal. We're just going to get a 3 there. So pi over 6 times x plus 3 is equivalent to pi over 6x plus pi over 2. All right. Once again, I can identify a, b, c, and d. And if I'm asking for period and phase shift, I need these numbers. Once again, the phase shift is real simple. Oh, and I messed up on the phase shift. That's simple that I messed up. But this is positive 3, and again, we always change the sign for d, so d is going to be negative 3. So my phase shift on this one is going to equal negative 3. The period, remember the original period of tangent and cotangent is pi, so to do period, I'm going to do pi divided by c. That's the same as pi over 1 times 6 over pi. Pi is canceling me with a period of 6. Okay, so again, tangent or cotangent in that case, regardless of what trig function it is, it's going to work out the same way. Again, pi over 6, because again, pi over whatever c is. Number 10, one full period of 2 cosine of 2/3 pi. A is equal to 0, d is equal to 0 in this case. If you wanted to write the whole thing out, y equals 0 plus 2 cosine of 2/3 times x minus 0. So once again, a is equal to 0, b is equal to positive 2. What that tells me is we got a centerline value of 0, we're going 2 up and 2 down. So we can imagine the y-axis as such. These two numbers influence the y-axis. I can see that c is equal to 2/3 and d is equal to 0. Right? What that tells me, d equals 0, is this is 0 and we're going this way. And since c is 2/3 and the period is going to equal 2 pi divided by 2/3, that's the same as 2 pi times 3/2, which is 3 pi. And that means the per dash is just 3 pi over 4. So 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4, better known as 3 pi. The way we've been doing this is just labeling it like so. Every dash represents 3 pi over 4 starting at 0. Finally, we're doing cosine. B is a positive value, and cosine either starts at the top or bottom. When B is positive, it starts at the top, so we're going to go Tobot for our points. So our first point is at the top, then we're at the middle, then we're at the bottom, then we're at the middle, then we're at the top, and we connect the dots with a nice smooth sine curve, or cosine curve, like so, and there is our graph. I'm expecting when I see a good graph, the dots of course are going to be in the right spaces, the y values are correctly labeled here, and the x scale is correct here for the dashes. Number 11, one full period of -3 cosecant of 1/4 x. Oh, real back to here. Expect this to be sine or cosine, so know your sine and cosine graphing technique. Expect this to be secant or cosecant. -3 cosecant of 1/4 x. So again, if I go to the full out version of this, it's 0 minus 3 cosecant of 1/4 parentheses x minus 0. So I can see that a is equal to 0, b is equal to -3, which means I'm going to go 0 here, 3 up and 3 down because the amplitude is 3. Imagining a sine function. Also, because it's from a sine function, if it was just a basic sine graph, b is negative, we go 0, bottom, 0, top, 0. Since we're doing a cosecant, all the zeros change to the asymptotes. So asymptote bottom, asymptote top, asymptote. All right, next I know c is equal to 1/4, which means the period is going to be 2 pi divided by a fourth, which is the same as 2 pi times 4 over 1, which is 8 pi, which gives me a per dash. Since we have 4 dashes, 8 pi divided by 4 is going to be 2 pi. So that tells me, of course, d is equal to 0. There's no phase shift. So I'm starting at 0. I'm going 2 pi per dash, 2 pi, 4 pi, 6 pi, 8 pi. And again, we're imagining this graph here, starting at an asymptote. So I want to put vertical asymptote in at the origin, a vertical asymptote at the middle dash, and a vertical asymptote at the last dash. Maybe. There we go. And then the first dot that I get to is going to be at the bottom, and the next dot's going to be at the top. So we stay in between the asymptotes at a maximum at the dot, stay in between the asymptotes and a minimum at the dot. And we get one full period of cosecant, -3 cosecant 1/4 x. So again, what I'm looking for is the asymptotes in the right spots, the y values are correct, and of course if your x scale is correct, any work you show me will count towards partial credit in case you do graph it improperly. Number 12, angle of elevation point A to the top of a tree is 40.7 degrees. At a point B, 49 meters from A and on a line through the base of the tree in A, the angle of elevation is 30 degrees, find the height of the tree. So, what they're telling me is there's some tree. There's the tree. It's very thin and not very vegetative. There's some point out here, A, where if I were to look up to the top of the tree from point A, like so, the angle of elevation to the top of that tree at that point is 40.7 degrees. Then, if I stay on the same line that I'm on from the tree to point A, and I come further out here to some point B, and it specifically tells me that this point B is exactly 49 meters away from A, further back. So again, A is right here, B is further back from the tree, 49 meters, and we measure the distance from the angle of elevation from point B up to the top of the tree. We find that to be 30 degrees. 30.0 if you wish. What I don't know is how far we are from the tree initially or the height of the tree. What I'm asked to find is the height of the tree. So my goal here is to find h. What I can find more easily is x, but once I know what x is, then I can find h. And what I need to do is focus on the two triangles in the problem. The first triangle, let's just call this C and this D just to give it names. Triangle ACD has an opposite h and an adjacent x of the 40.7 degree angle. So if h is opposite and x is adjacent, and I got an angle down here, an acute angle, the tangent of the acute angle should equal opposite over adjacent. If I cross multiply, that gets me h is equal to x tangent of 40.7 degrees. Then, if I take a look at the bigger triangle, BCD, BC, this side is 49 plus x. H is still h is still the opposite side, 49 plus x is the adjacent side. So I know that the tangent of 30 degrees is going to equal opposite h over adjacent x plus 49, or 49 plus x, take your pick. Cross multiply 1h is equal to tangent of 30 times 49 plus x. Now the trick to the problem is that h equals this expression, h also equals that expression, so these two expressions are equal to each other. My calculator knows what the tangent of 30 and 40.7 are, so if I ask it, and notice I'm in degrees, tangent 40.7 equals, tangent 30 equals 0.8601 for 40.7 and 0.5774 for 30 degrees. So this was 40 and this was 30. All right. So if I substitute those numbers in now, I'm going to get this expression here, which is going to be 0.8601x, is going to equal this value of this right here, changing tangent to 30.5774, 5774 times 49 plus x. So now we've got a basic equation here containing x. It's just a matter of solving the equation. A little distributive property there. 0.8601x equals 0.5774 times 49 is 28.2926. Plus 0.5774x. We'll move that to the other side. 0.8601 minus 0.5774. That comes out to 0.2827 is equal to 28.2926. So we divide both sides by 0.2827. 28.2926 divided by 0.2827 comes out to x is 100.0799. That's x. That tells me how big this dimension is, but we're asking to find this dimension. So once I know what x equals, once I know that answer, all I have to do is stick x right there and I'm going to work it out. I'm going to figure it out. So to get h, I simply have to take x, which is this, times the tangent of 40.7, which is that. So h is simply going to be 100.0799 times 0.8601. And that comes out to 86.0779. Go a couple decimal places, so 86.08. 86.08, and the unit of height is meters. You can see that meters is used in the problem, so that's everything's going to be meters in this problem. Most of you, this was like the bonus on the quiz that we did, 5.1 to 5.3 quiz. Most of you got it wrong that knew what you were doing, stopped here. You didn't find the height, you found the distance from the object. So be careful that once you find out what x equals, your goal is to find h. All you have to do is go right back there to figure that out. The bonus, which I'll put a similar bonus on the test, we have a hot air balloon floating 3,000 feet directly above a lake. All right, so imagine that we have a lake, and there's the span of the lake. So there's one side of the lake, there's the other side of the lake. We have a hot air balloon somewhere up here. Let's put it right there. This is the balloon that's above the lake. And it's 3,000 feet above the lake, so we know exactly this number here. That's 3,000 feet. It tells us the angle of depression to one side is 40, the angle of depression to the other side is 33. So what they're telling us is if this is the horizon going through the balloon, the angle of depression to one side is 40, and the angle of depression to the other side is 33. What that gives me for this triangle is this angle down here is 40 and this angle down here is 33, because the lake itself is horizontal to the horizon and this is a transversal. These are both acute angles for the same transversal. They're equal. Same deal there. They're equal. Now, the trick to this problem, and I hate using the word trick, but the way we're going to do this problem is I can find out this length focusing just on this right triangle here. Let's call that x. And I can determine this other length here, which is part of this right triangle. We'll call that y. Figure out x, figure out y, add them together, you got the length of the lake. So basically, I'm imagining some point C right here. So if I can figure out the length of AC and the length of CB, then I'm ready to go. And each of these is just a right triangle trigonometry. For the 40-degree angle, 3,000 is opposite, and x is adjacent. That means the tangent of 40 degrees should equal 3,000 over x. if I cross multiply, I get x tangent of 40 is equal to 3,000, which means x equals 3,000 over the tangent of 40. Similarly, looking at y, for this angle, this is the opposite, y is the adjacent. Same type of math involved here. Tangent of the angle 33 degrees should equal the opposite measure 3,000 over the adjacent y. Cross multiply, y tangent of 33 is equal to 3,000. So y is simply going to be 3,000 over the tangent of 33. And both of these have numerical equivalents. It goes over there so I can type on the calculator. 3,000 divided by the tangent of 40. So x is 3,575.26. And if we do 3,000 divided by tangent of 33, that comes out to 4,619.59. So if I simply add those two numbers together, I'm going to get the width of the lake. So 3575.26 plus 4619.59 comes out to 8,194.85 feet. 8,194.85 feet. All right, so there's your study guide. Hopefully this will help you to prepare for the test. Again, most of the questions will be of the same type. I might change up a trig function here or there. Know all your stuff about all your trig functions for every problem, and be aware of everything that's going on there.